Hi students, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. And students, we are doing class 12th NEET, right, for chemistry, and we have started our first lecture, and today is the last lecture of the first chapter, that is solutions, right? So till now in solutions, we have learned about vapor pressure, colligative properties, but today, right, very important topic, that is Vant Hoff Factor, abnormal normal mass, and the colligative property in addition of your when you inculcate Vant Hoff factor in the colligative property, right, what is the new formula that is generated, right? So we are going to talk about all these things. Let me know in the chat box if I am clearly visible and audible to you or not. Yes, everybody, everyone in the chat box, let me know if I am clearly visible and audible to you or not, right? And why the energy is so low? Yes, everyone, why energy is so low? Huh? Sure. Let's start with the class, right? We are going to talk about Vant Hoff factor, abnormal, normal mass, all of these things. And again, I am reminding you, kindly do your homework. You are not doing that, right? Only few students are doing that. Only one student, Ria, has done it, right? Rest of you have not done it, right? So without doing homework, it will not work, right? So please do your homework, do practice. That is equally important, right? Because 50% is theory and 50% is practice. So practice will make you perfect. For that, you have to firstly start with at least doing the homework, right? Now, if you talk about the homework, what I have given you, the size of raw mango shrinks to a smaller size when kept in a concentrated salt solution. Which of the following process can explain this? Size of a raw mango will shrink. That is because of the osmosis. So you can say answer will be A, that is osmosis, right? Next is KB is referred to as alebbioscopic molar elevation, both A and B, neither A and B. So KB is both A and B, alebbioscopic and molar elevation constant. Just like KF is cryoscopic constant, molar depression constant, that is your KF, right? Now the third question was colligative properties depends on number of solvent particles, mass of solvent, number of solute particles, total number of solution particles. So it depends on the number of solute particles. So answer is going to be C is the correct answer here. Is that clear to everybody? C is going to be the correct answer here. Now that was your homework, right? Now we are going to move towards Vant Hoff factor. But before that, let's understand what is normal mass and what is abnormal molecular mass. Right? Okay, everybody? Yes. So, let us start this. See, abnormal, normal molar mass, Vant Hoff factor included in your colligative property. These are the kind of questions that we ask you in the exam from this chapter, right? Okay, so that's why this lecture becomes automatically very important for you, and this is also the last lecture of solution chapter, right? So a lot of questions we are going to do, right? Just theory part will be your abnormal and normal mass that I'll teach you. After that, we'll study some formulas of Vant Hoff factor. After that, we'll have a lot of questions of NEET previous year questions, JEE previous year questions also I have picked up, because we know that JEE questions are repeated, molded version of the same kind of questions are repeated in your NEET, right? So that's why you will get an idea that how they can increase the level of the exam, right? Okay. So now firstly, let us understand abnormal molecular mass. Okay, why this happens? What is the reason behind that? See, if you talk about normal thing, right? So let's say I am talking about the mass of, let's say mass of any compound here I am talking about, right? Let's say mass of NaCl, right? Na is 23, Cl is 35.5. When you add it, this will become 5, 6, 7, 8, 58.5. That is the normal mass of NaCl. If you have one molecule or one compound, one NaCl molecule, then what you will have? The molecular mass will be 58.5. That is normal, right? Now, what if this mass increases or decreases than the expected value? That is called abnormal molecular mass, and that we have to study in this particular lecture, right? Why this happens? Why sometimes the mass of a compound, the mass of one compound that increases or decreases in a certain situation. Okay, so let's study firstly what is the definition. The experimentally determined molar mass that is in reality that is happening, that is either lower or higher, right? You were expecting something, it's like expectation versus reality, right? So when you were in the NEET exam, you expected what thing? You expected the paper is going to be easy, only like pattern will be repeated. But the reality was different, right? So in the competitive exam also this happens. You prepare for this level. The level can be more, the level can be less. If the level is same, we say it's a normal paper. If the level is less, we say it was so easy paper, abnormal. If the level is really high, like we saw in physics this year, right? That was abnormal paper for us, right? So if your expectation is not meeting the reality, that is abnormal molecular mass, right? Now we will understand that why this happens. First, you tell me if that thing is clear, that what is normal, what is abnormal. Because of certain conditions, the reality will be different from expectation, either lower or higher than the expected molecular mass. That is called abnormal molecular mass, right? Now, understand one thing, that there are two kind of situations that we are dealing with. One is dissociation, and the other is association. Other is association. Now understand one thing here, right? So when I talk about dissociation means, I'll give you an example of that. Dissociation means, let's say you have NaCl here, right? NaCl got dissociated into Na positive and Cl negative. That is dissociation, when a particular compound molecule gets dissociated into ions. That is called dissociation. Like for example, you have Al2SO4. Al2SO4 thrice. This will be dissociated into Al3 positive plus 2 of, you can just write it like this, plus SO4 2 negative, because aluminium is 2, so you will write it here 2. This is SO4 is 3, so you will write here 3, right? So a particular molecule is dissociated into its ions, that is called the dissociation process, right? Okay, now let's see this here. If I talk about dissociation, what is association? Who will tell me any example of association? Association is like you have the formation of dimer, you have the formation of trimer. This is this is association. Associate. Dissociate means to break, associate means to combine together, right? So you can take an example of this CH3COOH acetic acid. Its two molecules will combine together to form a one single molecule that will be dimer, right? If you want to see that how it is formed, it is through hydrogen bonding. Because of hydrogen bonding, that you will also discuss in P block, right? In inorganic chemistry, you will discuss about the dimers and trimers formation, right? So in dimer formation of acetic acid or benzoic acid, what happens? Because of the hydrogen bonding, it forms a dimer, a cyclic compound it forms, right? That is association. Now understand one thing, right? Is this clear? What is dissociation? What is association? That is clear to everybody, right? You have to connect the dots, okay? Nothing you have to do. It's not that of a difficult topic. It's a very easy topic. Just understand things individually, then we will combine them together. You have to connect the dots here, right? In the end, the picture will be absolutely clear to you, right? Okay, if that is clear, then let me know in the chat box. Right, guys, be little active in the chat box, right? That will be better for me, that will be better for you. Otherwise you will, I think otherwise you should learn from AI is very good, it's a very good teacher, right? If you want no human interaction, no emotions, then learn from AI. Why? Because AI will be like this. Hi, so this is this. We are going to do this. AI will be like, have you understood? You say yes or no to AI. It's like, okay, if they are not interested, I'll move ahead, right? That work is assigned to me. I am not AI. I am a human, right? So for a human, we need human interaction, right? Right now, we are not using AI technology in Vedantu, guys, right? Okay, teachers are teaching you, not AI bots are not teaching you, right? So you have to answer also, right? I think this Gen Z or Gen Alpha is like, this name may be AI, so we don't need to reply, right? Okay, Thalapati, I'll take care of that. You just behaved like my mom. Thalapati is like, put oil to your hair, ma'am. You just made me remember like my mom. She's like, put hair to your oil. Why are you doing this? Why you have colored your hair? Why are you doing this? Just made me remember her. Oh my God, Mama, you? Please come from the real ID, mom. So, let's see this, okay? Dissociation, this is association, right? Now, understand one thing. If you talk about abnormal molar mass, right? If you talk about abnormal molar mass here, right? I still can't get over that. Put oil to your hair. Okay. So, I'll take that very, very seriously. So, if you talk about abnormal molar mass, right? That is, now let's take, now you have to understand this very carefully. Firstly, tell me what is a molar mass? Molar mass, can I say mass of 1 mole, right, in grams, or mass of 1 molecule in AMU? If you have like understood what is mass of, C, if you talk about oxygen molecule, for 1 molecule, the mass is 32 AMU. Because it is a molecule, we'll just write U here, right? For oxygen, this is 1 mole. And if I talk about 1 molecule, this is 1 molecule. And if I talk about 1 mole, the numeric number is going to be the same, right? It is going to be 32 grams. Okay, that is the difference between when you talk about 1 mole and 1 molecule. When you talk about 1 atom or you talk about 1 mole of the atom, the numeric value remains the same, right? So that's why if you find it easy to think about 1 molecule, think about 1 molecule. If you find it easy to think about 1 mole, then think about 1 mole. That's totally your choice. But remember, right, if you're thinking about 1 molecule, then you are talking about 32U and here it is 32G. Why I'm saying that, you can also think about 1 molecule because the numeric value is same and our main funda is to look for the numeric values, right? Okay. So, if you see this here, what is a molar mass? Molar mass is mass of 1 mole. Molar mass is mass of 1 mole of compound, right? Okay, 1 mole of compound. So can I say that, let's say you have NaCl, right? The mass of 1 mole of compound expectation is, for 1 molecule it is 23 plus 35.5, that is 58.5. Okay, that is the expected value that you are having in your head, right? That the mass should be like this. But in reality, what is happening there? NaCl getting dissociated. See, what we are doing here, you have a beaker, you are talking about 1 mole of particle, right? Okay, you want to talk about 1 mole of particle. This is the molar mass of 1 mole of particles, right? But 1 mole of particle has changed. Why? Because of dissociation. What has happened here? Because of dissociation. See, 1 mole means 6.022 into 10 raised to power 23. Okay. And here, if you see, this is Na positive, this is Cl negative, right? In the expectation, right, we would have 6.022 into 10 raised to power 23 molecules of molecules of NaCl. That will, if we are assuming that there is no dissociation, then we are saying that this much molecules of NaCl mass we are calculating. But in reality, it is not NaCl. It has dissociated into Na positive and Cl negative. And here, if I assume 100% dissociation, if I assume that all the molecules, you have 50 molecules, those 50 molecules are dissociated, right? Then see one thing, right? See one thing. If I am assuming that here you have 50 molecules, these 50 molecules are dissociated, this is also 50, this is also 50. Now, if you pick out the mass of 50 molecules, that will be less than NaCl mass. Got it or not? Let's say I'll talk about one molecule, okay? I think that will be easy for you. Let's say you have one molecule. Here you will have one ion. Here also you will have one ion, right? Mass of one molecule should have been 58.5. But in reality, now the mass of one particle will either be 23 or 35.5. You can take the average of this thing, right? Okay, let's see what is the average that you can calculate here. 23 plus 35.5, right, divided by 2, that is 29.25. Now, we don't know whether this will be the mass or this will be the mass. It can be between 23 to 35.5, right? Okay, so that means the mass is going to decrease here. Understood this or not? That means the mass in dissociation for one mole particles, because if we are assuming that there is no dissociation, one mole, or I think about one molecule, that is giving you this thing. But in this case, one molecule is this thing or this thing, right? Similarly, if I talk about that here you have one mole, let's say you have here 6.02 to 10 raised by 23. So here also you will have, this will be 6.022, or I'll just write Avogadro's number. This will also be Avogadro's number if I assuming one mole. Now one mole will be, right, somewhere between 23 or 35.5 or slightly greater than, but surely it is less than 58.5, right? Tell me if that thing is clear to everybody or not, why the mass is decreasing, right? It's like, I will give you a general example here, right, related to your daily life. So how many of you like burgers? How many of you like burgers? Do you like, what's your favorite, burger or pizza? I to hate both of them. My favorite is dosa, right? So, chalo, I'll have dosa here. You have one dosa, right? Now, I'm saying that I want to calculate the mass of 50 dosa. 50 dosa pieces. Now, here I have not divided it into half. I have not dissociated it, right? But now I am like, if I dissociate, let's say I have 50 dosa pieces, but the students are 100. Now I'm like, oh my God, it's my birthday party. It's not my birthday now, but let's assume it's my birthday party and you guys are like joining me. You are guys, ma'am, we have cracked meat, ma'am, let's celebrate your birthday together. I'm like, okay, let's celebrate. So dosa ma'am will definitely give you dosa only, na? So I'll give you dosa. So I assume that 50 students will come. So what I assume that, okay, I ordered 50 dosas, but in reality there were 100 students. Then I assume that what to do now, right? It's raining outside, no Zomato delivery guy is available, right? So what ma'am did, ma'am was like, okay, this is your one dosa, I'll divide it into two, right? This is one dosa and this is other dosa. Now half dosas I'll provide to all the students, right? Now, if I want to calculate the mass of 50 dosa pieces, that will be half of this, because if this is 50 dosa pieces full, right, then this will also be 50. This will also be 50, right? Because 50 dosa you are dividing. So in total you will have 100. This will be 50. This will be 50, right? So mass of 50 dosa pieces will be half of this, right, what we have calculated here. Because now the mass of 50 dosa pieces is different because dosa piece has changed. Here dosa piece was full, here dosa piece is half. Similarly, here you have, here we are calculating mass of 1 mole. Here 1 mole is NaCl. Here 1 mole is either Na positive or Cl negative. So mass is definitely going to decrease. Right? Okay. Understood? Right? Yes, everybody. Is that clear? Is this point clear to everybody or not? Let me know in the chat box. Right? I think by this dosa example, it would have been more clear to you. Right? I have 50 dosas. There are 100 students. I'll divide it into half and half. Right? Now I want to calculate the mass of mass of 50 pieces only. How many 50 students have eaten how much mass? Right? That I want to calculate. Ma'am is a very conjuice ma'am. That I am not, right? I'll never calculate the mass of the dosa pieces that you have eaten. Trust me, I'll never calculate that, right? So here, if you see this one more example, right? So this is in a little chemical way, right? So you have a beaker, you have KCl, that is, we know that the mass of KCl is 74.5 gram. Mass of 1 mole of KCl is 74.5 gram. Now you have dissolved it into water. In water, dissociation will occur. 1 mole is dissolved. So you will have 1 mole of K positive, right? And 1 mole of Cl negative you will have here. That means dissociation has occurred. Now logically, 2 moles of particles in the solution. Can you see? This was 1 mole. This has given you 1 and 1 mole. So logically, you have 2 moles in the solution, right? Okay, so now what you will do here, 2 moles of particles has this much gram weight, right? Because here 1 mole has 74.5 gram, but that 1 mole has dissociated into 2 moles. So now we can say 2 mole has this much gram of mass after dissociation. So that's why 1 mole will have half of it. So you will have this as the answer. Here I am considering that 100% dissociation is there. Every single particle is, I am dividing it into 2. It's like I am fully loyal to you. 100% is, I am fully loyal to you. It's not like, oh, that's my favorite student. He or she always attends the class, always do their homework, so I'll give them full dosa. And to other students, I'll give half dosa. No, I'll not do that, right? So 100% dissociation will be there. Now, if I'm like, okay, this student is attending my class on daily basis, doing the homework, so I'll give them a full dosa with chutney, sambar, everything, right? Now, someone is not attending the class, right? So I'll scold them, never, you have not attended, so only half dosa will be there. I think I'll prefer this, right? Because only then you will be able to do your homework, right? So that was there. So expected increase, a very, very important point here, right? So can we say that, just ignore this point here for now, right? Can you see there is abnormal molar mass? Mass decreases in case of dissociation. Can I write mass decreases in case of dissociation? Right? Okay, very good, very good. Now, let's talk about abnormal molar mass in case of association. Okay? Let's talk about abnormal molar mass in case of association. When things are combining, associating, right? Associate partners, because they are joining hands with each other. Association means when they are partners, right? So here it is associating. So I am assuming that you have CH3, COOH, right? This is 2 molecules of it will dimerize to give you this thing. That is association, right? Understand one thing. Firstly, tell me what is the mass of CH3COH? Carbon 12 and 12, hydrogen is 4, oxygen, carbon is 24. 24 plus 4, it is 32. 4, 4, 8, 10, 3, 4, 5, 6, 60, right? CH3COH has 60 gram per mole mass, right? So we know that 1 mole of, just write 1 mole of non Unassociated. I don't know if this is the word or not, right? Unassociated, right? Unassociated CH3 COOH molecule will have 60 gram per mole of mass. In 1 mole, you will have 60 gram per mole, right? Now we know that here it's like you have one person, right? Okay, I'll tell you one funny example of this. Now, this is your friend who is single, right? Who is single, right? You have invited your friend, right? You have invited your friend to the birthday party. You don't know the friend has associated, right? And this is a friend, right, who is not single, right? So, this friend has a partner, right? This friend has a partner. Let's mention partner here, right? This friend has a partner, right? All of them don't have legs. So let me just make their legs, right? Because that is also very important, right? Sure. Okay. So all of them are happy and this is the friend. Okay. Now, this is association. You were assuming that, what you were assuming? You invited, see, we know that whenever we invite someone, right, to a party, we always calculate that what will be the budget. Okay. You called up your friend, you're like, hey, I want to invite you for my birthday party. So this is there and there, you can come and join, right? So that's it. What happened in reality, right? Your friend was not single, right? So he came with his girlfriend, right? Or boyfriend. Now you are like, oh my God, what has happened? Would my price has increased. You will eat 2 plates. I thought about 1 plate, right? The amount will increase. I'll have to pay more price because of their association, right? Your plate price will increase. You will have to pay more, isn't it? Same thing will happen in case of CH3COH, right? You were thinking that 1 mole, right? What you were thinking that I want to focus about 1 mole, right? So in your assumption, right, you were thinking about 1 mole, right? So we know that expected is that 1 mole will have 60 gram per mole. But in reality, because of the association, 1 mole is not 1 mole now. 1 mole has a girlfriend now, right? So 1 mole is in a couple situation now. So you'll have to pay double, right? So what will happen in reality, what will happen here? In reality, what will happen here, right? This will be 120 gram per mole because now 1 mole particle is double of this. Here you have 1 mole particle. This is 2 mole. This 2 mole is giving you 1 mole, right? This 2 mole is giving you 1 mole of CH3COH twice dimer. So that's why its 2 mole particle is the mass of its 1 mole, right? So that is 120 gram per mole. Is that clear to everybody? Right? Okay. Trust me, in this much detail, nobody will teach you normal mass. Right? Okay. I know that is a query of all the students. What exactly is abnormal mass? Right? So understand it this way and will be very beneficial for you. Okay, everybody? Got it? Shall I move ahead? Okay. Now, let's see this chart here. Right? So you have formed a dimer because of the hydrogen bonding that has increased. Because of dimer association, number of particles decreased in, if you say in 1 mole, right, number of particles has decreased. That's why mass will increase here. 2 mole after association will become 1 mole. That's why the mass will increase. So abnormal molar mass is more in case of association. You can say increases in association. Increases in association. Okay. Yes. Now let's see this thing here that is very important, right? Okay. Now let's see. What they have observed is this mass is also affecting delta TB, delta TF, right? Molar mass calculated on the basis of this and this is twice of the normal value. Molar mass has increased. But what they have observed is delta TB, delta TF is half of the normal value. Boiling point, freezing point change has also increased or decreased, right? So now that means there is some relation because of this mass increment or decrement, the colligative property has changed, and for that we will understand Vant Hoff factor. Okay, so abnormal mass in dissociation it is lower, and in case of association it is greater than the true value, that is the expected value. Okay, now let's talk about very important thing, very important points here. The solution must be non-volatile. What are the conditions, right? Accurate molar mass, if you want to calculate, the solution must be non-volatile, right? That means it should not form vapors here. The solution must be dilute, that is concentration of the solution in the solution, solute in the solution should not be more than 5%, right? Third is the solute should not undergo either dissociation or association in the solution. Only then. See, if I am saying that NaCl has 58.5 mass, this is only calculated in these conditions. First thing is it should not be associated or dissociated, right? The solute concentration should be less than 5% and it should be non-volatile so that there is no vaporization in that case. Okay, right? Only in that case you will be able to find the accurate value of molar mass that we actually write. Okay, now next is going to be the Vant Hoff factor. Let's understand that, everybody. Let's understand Vant Hoff factor. Okay, dissociation should not occur. Dissociation will occur whenever you add water. If the compound wants to dissociate, you can't stop the compound, right? Yes, but the condition is that dissociation should not occur, only then we can calculate the molar mass, right? Okay, now let's see this here. Vant Hoff factor, right? If you see, the formulas are going to be I is equals to normal molar mass that you were expecting divided by abnormal molar mass, or you can say expectation. Normal na, expected normal mass by reality abnormal mass. Okay, expectation by reality, you have understood the memes that you see on Instagram and all. Expectation by reality, that's why you have to remember. Observed colligative property is the expectation, right? Okay, observed colligative property is the reality and calculated is the expected, right? What you will calculate from your formula, that is the expected value, that you are expecting that from this formula the delta T value, delta TB, delta TF value should be this, but in reality it was coming out to be different, right? So that is your another formula of Vant Hoff factor, right? Then another formula is total number of moles of particles after association or dissociation divided by number of moles of particles before association or dissociation. Considering that association or dissociation is doing alpha percentage here, right? Okay. So I'll tell you how we are going to do this. For example, you have NaCl. Okay. NaCl is getting converted to 2 moles. So number of moles of particles after association, dissociation, it is 2. Number of particles before association is 1. So answer will be I is equals to 2. Okay. But it's not that simple. Here I am saying that the dissociation is 100%. Every single molecule is getting dissociated, right? In that case, you can easily find out, right? In that case, Vant Hoff factor will be equals to the number of particles that is associated or dissociated, right? But if you talk about there is alpha percentage, then what will happen? Okay? Okay, let's solve this, everybody. Thank you so much. Kruparo, thank you. Okay, now let's talk about what is degree of dissociation. What is degree of dissociation? Right? Degree of dissociation is number of moles, right, after dissociation divided by initial moles. That is degree of dissociation. After dissociation by initial moles, right? That is degree of dissociation. Now, let me just write down the formulas of this thing here, right? We will also derive. If you want me to derive the formulas, I'll derive for you so that you get an idea what is happening here, okay? So, let's understand this thing that in dissociation, what is happening? Everybody tell me in dissociation, what is happening? Tell me, bacha, in dissociation, it is being dissociated, divided into molecules, okay? So, I am assuming that here you have, I'm assuming that here you have, this is, let's say, A, this is, let's say, n amount of A. Dissociation, no. Let's say this is AB, but I don't want to get into AB, right? Dissociated we have to see. Let's say you have A and this is being dissociated into 1 by Na, right? Because the molecule is getting divided, dissociated, right? Okay, so initially it is A, now it has decreased to 1 by N of A. Or you can also write it something like this. This is A, B, this is being dissociated into A positive and B negative. But in that case, the formula generation will be difficult for you. So I'm just writing it directly. This is A, this is getting converted to 1 by Na, or you can say N amount of A. This An is, this is, I think that will be great. An is getting converted to N amount of A positive. This is dissociation, right? Just like you had NaCl, you had one molecule that was converted to 1 Na and 1 Cl that is converted to 2. So 1 is getting converted to 2. So 1 can also get converted to 3. 1 can also get converted to 4 particles. 1 can also get converted to 5 particles. Understood? That one compound can dissociate into 2 particles, 3 particles, 4 particles, 5 particles, 6 particles. So N is representing if it is dissociating into 1 particle, 2 particles, 3 particles, 4 particles, 5, 6, 7, 8, 9, 10 particles, whatever particles. Okay, so I'm generally writing here N, right? If N is equals to 2, so it will be A2 is getting dissociated into 2A positive, right? If it is 3, so it will be 3, right? So that is my N value, right? Okay. Now, what I am going to do is write the value of dissociation. Let's say initially the value is, let's say it is, what you can write, we'll just make it as 1, right? It is 0, right? So now alpha amount has been taken out here, right? This is 1 minus alpha. This will be N alpha is formed, right? Okay, N alpha is formed here. Now, if you see that, what is the value of Vant Hoff factor? What is the value of Vant Hoff factor? The formula was number of moles particles after dissociation, before dissociation. After dissociation, see, before dissociation, the number of particles is 1. After dissociation, if some, I don't know how much amount is being dissociated, right? I am assuming it to be alpha. So, how much amount is being number of particles after dissociation? You have N alpha, right? Okay. And number of particles before dissociation, what you have is, right? Before dissociation is what you have. This is 1, 0, 1 minus. Okay, this also should be, stoichiometry is 1, na? So this is before dissociation. Wait a minute, number of moles of particles before association or dissociation, right? That means I'm assuming that number of moles of particles is 1. So that will be 1. Wait a minute. Wait a minute. Wait a minute. after dissociation, this will also be the particles, na? That's where I did the mistake. Wait a minute. Yes. Wait a minute. Where it is? Yes. So let me just write it again. If you talk about the number of particles after dissociation, that is this full. Because in that beaker, you have En also, you have Na also. Because I don't know how much dissociation is there. If let's say the dissociation is 50%, so 50% of particles will be En and 50% of particles will be N amount of A positive, right? If it is 70%, that means 70% will be Na and 30% will be An, right? That means if I give you the example here, if you have NaCl, it is being dissociated. If it is, let's say, dissociated to only 30%, that means 30 particles will be of Na positive, 30 particles of Cl negative, and 70 particles will be of NaCl if you have here 30% dissociation. Okay, right? If you have 30% dissociation, then 30% will be of Na, 30 will be of Cl, because 30% is dissociated. Rest amount will be NaCl, right? So I am writing it in the straight way. A direct definition, you can say that I is equals to number of particles after dissociation is 1 minus alpha, that is of En, plus N alpha. Now initial will be your 1, so answer is going to be this as your final answer. That is your formula of, that is the formula of I Vant Hoff factor in case of dissociation. Okay, this is in case of dissociation. This formula you will write alpha is degree of dissociation, and if you talk about N is the number of particles dissociated. Number of particles it is dissociated into. It is dissociated into, right? For example, I am writing that, let's see, for Al2SO4 thrice, what is the value of N? See, it will be dissociated into how many particles? One is Al3 positive, that is 2 particles, plus SO4, because we know that this is formed by cross multiplication that you have studied in 9th class. If you're not able to understand this, go and watch my lecture of some basic concepts that I have taught you in 6 p.m. lecture, right? So that is this. 3 plus 2, that is 5. So that means the value of N here has to be 5. Now, second example that we can assume here is, let's say you have Na2SO4. How many particles it is dissociated into? Yes, everybody, how many particles it is dissociated into? Na2SO4. 2 particles of Na, right? Plus 1 particle is SO4, 2 negative. So can I say N is equals to 3 here? So N will vary, that they will give you the compound in the question. From that you can easily see what is the value of N. Alpha, if it is not given, then you will take it as 100%. If it is given in the question, then you will put that value, right, in the fraction, right, and you will get the value of Vant Hoff factor. If alpha is 100%, then if you put alpha is, you can also write it here. You can also write it here, important point, you can just mark this here. If alpha is 100%, Vant Hoff factor is equals to N. That means if alpha is 100% in case of, let's say this, then Vant Hoff factor will also be equal to 5. In this, Vant Hoff factor will be equals to 3 if there is 100% dissociation. Okay, yes everybody. Now let's talk about association. Okay, let's talk about association. Let's talk about association. I think now association will become very easy for you to understand, right? Association. So how you will do that? Anybody? Association means you have n number of A particles, right? You have n number of A particles that is being associated to N. Like CH3COH was dimerizing. In that case, N is equals to 2. In a trimer, N is equals to 3. In a tetramer, N is equals to 4. Right? Okay. Now, that is your dimerization, right? That will be dimer, trimer, tetramer, whatever. Now, initially, I am assuming it to be 1. This you have studied in ionic equilibrium, okay? So, that's why, again, I am teaching you, this is 1, and this I am assuming that initially there is no association, so I am assuming it to be 0. After association, how much amount will be subtracted here? Anybody? 1 minus n amount of alpha, because alpha is always subtracted by multiplying with stoichiometry. This is stoichiometry, so it will be n alpha. And here what will be formed? Also, you know what you can do. So n minus alpha, and this will be how much amount will be formed? Alpha amount will be formed. Right? Okay. You can do it like this as well. Right? There is another way of doing this also. You can do it in this way as well. If you solve this as, this is n 1 by 2. Sorry, 1 by 2 I am writing 1 by n. Right? They are saying that if instead of writing, I am giving you with the help of examples also. Let's say you have CH3COH, this is 2, this is give rise to CH3COOH twice. You can write it like this, or you can write it also like this, that you take the initial moles, because you have taken initial moles as 1, right? Okay. So I would advise you, if you take it as 1, this will be 1 by n. Sorry, 1 by 2. Okay. Here also, if you are assuming this now, then initial moles you can't take 1 in fact. Initial mole you have to take n, this will be 0. This will be n minus n alpha, and this will be alpha. Right? If you solve it this way, then it is going to be this. Right? So you can solve it both ways. Okay? I am writing it in both ways. You don't need to be rigid in one way only. You can also write it in this way. Otherwise, students are like, ma'am, why this way, ma'am? Why not that way? You can also write it that way. That's totally your choice. You will get the same answer. Right? But in this case, you can take initial mole as 1. This is 0. This is 1 minus stoichiometry multiplied this. So stoichiometry is 1, so it will be alpha. This is 1 by n alpha. This will give you the same answer. Right? First, you tell me if that thing is clear. In some books, you will see this. In some books, you will see this. That is the same thing. Okay? If that is clear to you, then let me know in the chat box. I solve it in both ways now, you will get the same answer. So let's solve this in both ways. If I solve it this way, right? If I solve it this way, you will get I is equals to initial final moles after association is n minus n alpha plus alpha divided by initially it is n, right? So you can also write it as, if you take n as common, so you can also write it as n 1 minus alpha. This will be n, right? So you can also solve it when you will divide it by n. This is divided by n. This is divided by n. You will get the answer as, this is 1 minus alpha plus alpha by n, because I had less space, so that's why I have written it by erasing only, right? You solve it this way also. This is I is equals to final moles after association is this, right? Here it was this. Here initial was n, here initial is 1. Ma'am, why here you have taken initial as n? Because stoichiometry it is giving n. Here stoichiometry is 1, so I can take it as 1, right? That we have learned in ionic equilibrium. That's why class 11th is very important. This is the final moles after association. Initial mole is 1, so I'll write it this way. That is nothing but the same thing, right? So why we prefer this thing, but directly you will get your answer here. But in this case, you will have to solve it, right? Okay. Okay. First way is easy, ma'am. Totally your choice. I find this easy, you find this easy, right? Your choice, right? Okay, right? But we are getting the same answer. And in the exam, you don't have to do any derivation. In the exam, you just need to remember that this is the formula. You just have to remember that this is the formula for association, right? Where n is equals to number of moles associated, right? How many number of moles are being associated? 2 moles, 3 moles, 5 moles, 6 moles, how many moles, right? And this is your formula for, and you can see, where should I write? This is the formula for, your, yes, this is the formula for dissociation, right? Both are same thing. I is equals to 1 plus alpha. Here it is n alpha, and here it is alpha by n, right? Okay. Yes, everybody. Perfect. Right? Now, these are the two formulas that you have. Now, see one thing, this also they can ask you. You will see that in case of dissociation, if I give you an example now, I'm also giving you the ways, if you forget this in exam, how you will like do this, right? Because this is actually a very simple chapter, okay? So if you have NaCl, consider 100% dissociation. Initial moles, we know, fine. Vant Hoff factor is final moles by initial. After association, the moles will be 2. It will be dissociated into 2 cases. Initial mole, if I take it as 1. So, I is coming out to be greater than 1. So, that's why always in case of dissociation, I will be greater than 1. You see any case. Vant Hoff factor will always be greater than 1. Right? And in case of association, even association, if you see this, no? This will be CH3, COOH, this is 2, this is 1. CH3, COH, this is twice. This will be initial, after association, the moles is 1, before it is 2, so it is coming out to be 1 by 2, which is less than 1. So always it is going to be less than 1. You pick out any case, any dissociation. I have just given you one example of 100% association and dissociation, but you pick out any association, dissociation, any formula, any percentage of association or dissociation, you will always get here I is less than, here I is greater than 1. Okay, is that clear to everybody? Malik, what should I repeat? Can you just let me know in the chat box, what should I repeat? Okay. Yes. But sir, you know what? I forgot to bring my water bottle, right? So after this, na, I'll just quickly go and bring water bottle because right now, so I really need it, right? Now, Vant Hoff factor, right? How it affects the constant, how it affects the colligative property, you can see from here, right? Every single, this is mole fraction, this is molality, this is your concentration, right? All the concentration terms are multiplied by the Vant Hoff factor in every colligative property. Here it is multiplied like this, here it is multiplied here, here it is multiplied here, here it is multiplied here, right? So all the 4 colligative properties in a revised version are written like this. Okay. Then ma'am, the formula that we have used before is wrong? No. If you have non-electrolytes, okay? If you have non-electrolytes, let me just show you. If you have non-electrolytes, in that case, you will take Vant Hoff factor as 1. Like in case of urea, sucrose, glucose, you will take these things because they are non-electrolytes, you will take it as 1, right? And also, if there is no information about solute, they are saying that find the mass of the solute, these kind of questions are there. If they have not given you any information regarding Vant Hoff factor, there is no information regarding solute, then you will take the Vant Hoff factor as 1. You will assume this. Then for strong electrolytes, if there is no information about alpha, then alpha is taken as 100%. And I is equals to number of ions in that case, if there is strong electrolyte in that case, or there is no information about alpha, right? In all these cases, we will take it as 100%, that is, we will take I is equals to 1 in these cases, and in this case, you will take alpha as 100%, then I will be equals to number of ions. Let me know in the chat box if this is clear to everybody. Right, definitely, Ria, I need to, I think, go and quickly bring water bottle, right? And let's see how many likes. You have not even crossed it 50. What you guys are doing, I don't know what you guys are doing, right? You guys are to like, ma'am, you do hard work, we don't care about you. That's what I feel. Even my, My limit will exceed sometime, right? Okay, so before, chalo, I'll give you some time and solve this question. Let's see, A, B, C, D. I'm giving you full time here, right? Okay, I'll also put the timer here, right? Let's put the timer. Okay, let's see in how much time you're able to solve this. Okay, let's see this. What is the answer? Option B, option D, option C, option D and B I am getting in the chat box. Right? What about other students? Let's solve this, okay? Let's solve this. So, here it is. The Vant Hoff factor for dilute aqueous solution of strong electrolyte of barium hydroxide. Barium hydroxide. See, we know that barium is 2 positive. This is OH negative. Cross multiply, this will become BaOH twice. Right? Now, when you dissociate this, you will have the same ions, Ba2 positive plus OH negative. But OH negative is 2, so here you will write 2. That means the number of particles that is equals to 3. Right? The Vant Hoff factor for dilute aqueous solution for a strong electrolyte. Strong electrolyte means 100% dissociation. Right? Strong electrolyte means 100% dissociation is there. Right? So can I say that Vant Hoff factor is equals to N is equals to 3 in this case. So answer is going to be D is the correct answer. Definitely right. That is D is the correct answer. That is 3. Yes. Option D will be the correct answer here. Okay. So how many of you got it correct? Let me know in the chat box. Right. Next is which one of the next question is which one of the following electrolyte has same value of Vant Hoff factor as that of Al2SO3 SO4 thrice? If this is basically like this. This is basically like this. Al2SO4 thrice. Okay. 100% ionization we are considering, right? They are saying which of the following have electrolyte same value of Vant Hoff factor I as this. See, 100% ionization means I is equals to N. And in this case, what is the value of N? What is the value of N in this case? 2 of Al3 positive plus 3 of SO42 negative. So N is equals to 5. So here I is equals to 5. Can I say that? Here I is equals to 5. So I need to find that in all these cases which has Vant Hoff factor is equals to 5. That means in which case your number of ions it is dissociating into is actually 5. Right? Okay. Let me know in the chat box, students. Yes, everybody. Yes, everybody. Let me know in the chat box. Right? Let's see that. Okay. So first thing is you have AlNO3 thrice. See, Al is always existing in Al3 positive, so it will be Al3 positive, right? And if you see NO is existing in NO3 negative, right? Because this is only one molecule, you have written 1 here. This is 3 molecules, so you have written 3 here. So N will be equals to 4, right? I is also equals to 4 in that case, right? What about the next one? This is very interesting. So in any coordination compound, always the inside of the bracket, so this is K4FeCN6, right? Always the one which is inside the bracket, that will never ever dissociate. In a coordination compound, the things that are inside the bracket will never dissociate, okay? So this will stay as it is. This will be K4, and potassium belongs to group number 1. It exists in K positive. You have 4 of K positive, so you will write 4K positive, right? This is existing as full bracket here. The things that are inside the bracket will stay as it is. This is 4. So here it will be, this is positive, this will be negative. So it is 4 here, so this will be 4 negative, right? So that's how you write it. If you're not able to understand this, we will do this in our coordination chemistry as well, right? So this is 4 negative. So ions is 1, and this number of ions is equals to 5. That means B will be the correct answer here. That's a very, very good, very, very good, right? B will be the correct answer here. Right? Okay, acha. What about the third one? Okay, this will give rise to, this is K2SO4. This will be dissociated into 2K positive plus SO4 2 negative. So N will be equals to, 3. Okay, last one is you have K3FeCN6, right? And here it is, K positive is 3 because 3 times you have K, and this is plus FeCN6. This is 3, so it will be 3 negative. So here N will be equals to 3 plus 1, that is 4. So only in B case you have Vant Hoff factor is equals to 5. Clear everyone? Okay. So that is not exactly a mixture. I think this is a basic thing of coordination chemistry. If you have studied even a bit of coordination chemistry, this would be easy for you. Okay. Now, next is the boiling point. Next question is the boiling point of 0.2 mole per kilogram solution of X in water is greater than equimolar solution of Y in water. Which one of the following statement is true with respect to this thing? Right now, this is a very, very interesting question. Right? So let's see who is going to answer this. Right? First, you have to understand boiling point of 0.2. This means molality of this much solution of X. Mole per kilogram means this is molality is given to you. This is molality of X, right? Or in water is greater than equimolar solution of Y. That means this is also the molality of Y because it is equimolar. Molality is same, right? Which one of the following statement is true in this case? If molality is same, then greater than this. They are saying boiling point of TB of X is greater than TB of Y. Okay. Now they are saying that why this is happening. Molality is same, but the boiling point is increasing. Beta, we have studied this in association, in case of association and in case of dissociation, right? What we have studied here, that in case of dissociation, right, the molar mass was decreasing, but the boiling point was increasing, right? In case of association, it was increasing. Wait a minute. Molar mass of X is greater. X, Y is undergoing dissociation in water. X undergoes no change. X is undergoing dissociation in water. Okay, Y, X undergoes no change. Y is molecular mass of X is more than molar mass of Y. Okay, molar mass of X is less than molar mass of Y. So basically, this is a case of dissociation only, where the mass is greater, because X has greater boiling point, so it must have undergone dissociation, hai na? So I think the answer would be C. Yes, C is the correct answer here. This you don't need to actually do all of this. Okay, this you can easily tell with the help of direct you can just tell this with the help of like concept also. Okay, concept is that in case of association, this is dissociation. Okay, in case of association and dissociation, what is happening here? In case of association, right, mass, molar mass, abnormal molar mass is definitely increasing. Here mass is decreasing, right? If mass is abnormal, mass is decreasing here. That's why the vapor pressure, the boiling point is increasing here. Because mass is decreasing, vapor pressure is decreasing, and vapor pressure is directly inversely proportional to boiling point. So boiling point is increasing. That's why boiling point of X is greater than this. So answer would be X is undergoing dissociation in this. Right? Molecular mass of X and Y are different, or this will not happen. Why? Right? Because we are not sure about that thing. But this thing we are sure that if the molality is same, right, in that case there must be some link with the association or dissociation. Right? Okay. So I daily join the class. I go live at, not daily, at 8 p.m. I go live, right? At 8 p.m. we take the classes for 12th class and at 6 p.m. for 11th class, right? Okay, you can see the Telegram channel schedule is like updated there daily, on daily basis, right? Okay, now let's do the next thing, that is, next question is 0.1 molar aqueous solution of weak acid is 30% ionized. Kf for water is this. The freezing point of the solution is going to be what? Okay. Molality is given to you. See, simple thing is delta Tf is equals to Vant Hoff factor Kf into molality. Right. Now, if you see this here, right, weak acid alpha is given to you. Molar solution of weak acid is 30% ionized. Aqueous solution is given to you. Okay, that means Tf naught will be equals to 0 degree Celsius, right? So Kf for the water is this. Okay, freezing point of the solution is what? See, if nothing is given about the acid, now what we will assume here, that they are talking about monoprotic acid. Let's take an example of Ha, that is H positive plus A negative. Right? If nothing is given about, see, they should have given us monoprotic, diaprotic, but if nothing is given to you, you take the general case. That is monoprotic, that means it is giving you one acid here, one H positive. So if you see this here, I is equals to, in case of association, is 1 minus alpha plus N of alpha, right? N will be equals to 2 because it is dissociating into 2. So it is 1 minus 30 by 100. That is 3 by 10. So you can write it here 3 by 10. Why we are writing 3 by 10? Because alpha is equals to 30%. That is 30 by 100. That is 3 by 10. That is 0.3. Right? So you can just write it here 1 minus 0.3 plus 2 into 0.3. Right? This will become 0.7, 0.7, 0.7 plus 0.6. Right? 1.3 should be your value of Vant Hoff factor, right? Okay, so Vant Hoff factor is given to be 1.3. This is Tf minus Tf naught. See, there is depression in the freezing point, so the answer will be Tf naught or larger minus smaller, right? Because Tf naught is greater or Tf is greater. Depression means freezing point has decreased. That means Tf naught is greater. So it will be Tf naught minus Tf. Right? So you can see this here, larger minus smaller. Vant Hoff factor is 1.3. Kf is given to be 1.86. 1.86. Molality is given to be 0.1. and TF naught is 0 degree. So you can just write it here 0 degree, right? So this will be 0 minus TF. So value of TF will be negative of what you will see here, minus 1.3, 1.86 multiplied by 0.1. Okay, solve this and you will get your answer here. Let's see what is the answer that we are getting. You solve this without the help of calculator. For me, it is allowed. Okay. So 0.2418 is what we are getting, minus 0.2418 degrees Celsius. That is nothing but D will be the correct answer here. Okay, right everyone? Got it? Okay, ji? Okay, calculator is not allowed in the exam. Okay, so you have to solve on your own. Okay, calculations, right? So then you will solve your answer and you will get the answer here. Next is the next question of your previous year question only, guys. Let's solve this. Let's see this question and let's solve this, okay? I think by now it should have increased 70 plus likes. Oh God, I so can't believe you guys, huh? Even after saying it's just 40, huh? Why are you doing this? Right? Share this with your friends, guys. Do like this session. Share this with your friends. Spread the word. Right? That would be great. Right? Now, let's see the next question. The Vant Hoff factor I for a compound which undergoes dissociation in one solvent and association in other solvent is respectively. Vant Hoff factor for a compound which undergoes dissociation in one solvent, association in another. See, in dissociation, Vant Hoff factor is less than 1. In association, it is greater than, in association, it is less than 1. Okay? And in dissociation, it is greater than 1. So, in dissociation, greater than 1. In association, it is less than 1. Okay? Some solvents, what they do is, for example, you put acetic acid in water, that will dissociate. But acetic acid in benzene, it will not dissociate, it will associate. Okay. So depending upon the solvent also, it changes. So when I was giving the example of acetic acid, it was in the benzene that was being associated. In case of water, it will dissociate. Okay. Okay. That's it. Chalo. Next is 0.5 molar. Next question is 0.5 molar aqueous solution of a weak acid. Right? See, I am doing as much practice as possible. You can see for yourself, right? Right now, we have done 5-6 questions already. Right? So, 0.5 molar aqueous solution of weak acid is 20% ionized. Kf for the water is this. Lowering in freezing point of the solution is what? Delta Tf you have to calculate. That is I into molality into Kf. Vant Hoff factor we have to calculate here. Who will calculate the Vant Hoff factor as fast? Let's see. Chalo, by the time I'm making a line that is straight, right? Okay. Okay. Vant Hoff factor in case of dissociation, weak acid, they are saying it's the same as what we did before. Y is equals to 1 minus alpha plus n alpha, n is equals to 2 because this will be dissociated into H positive and X negative. So it will be 2. So it will be 1 minus 0.2 because alpha is equals to 20%, that is nothing but 0.2. 20 divided by 100, that is nothing but 0.2. Right? Okay. Yes, everyone. So this is 2 into 0.2, right? So that is going to be 0.4. This is 0.8 plus 0.4, right? That is 1.2, right? Okay. Now what we are going to do, just put this in this particular formula. So it is going to be, see, even if this is given in degree Celsius, that will be same only. Difference whether it's degree Celsius or Kelvin, that is same only. You subtract 100 minus 0 degree Celsius, that is 100. You subtract 373 Kelvin minus 273 Kelvin, that is also 100. So even if it is in degree Celsius or Kelvin, that is the same thing. Okay, don't get confused here. Some students, they convert it into Kelvin, right? Don't do this mistake. This is 1.2. Molality is given to be how much, guys? Molality is given to be 0.5. Kf is 1.8, right? 1.86. Multiply this and you will get your answer here, right? Remember that they are asking the lowering in freezing point, is it? Lowering in freezing point. That means delta TF they are asking you. So delta TF will be your delta TF will be positive only, right? So either answer will be 1 or answer will be 2. So this will be 1 point. You can also do it easy way, right? You can also do it like this, okay? So this is nothing but 1 by 2, okay? So this is nothing but 10. So you can just solve it like this also, right? That's totally your choice. Obviously, you will solve it like this. This is 2, 6. This will be 0.6 multiplied by 1.86, right? Okay. What will be the answer? 1.12 Kelvin is going to be the answer here. Okay, right? Chalo. Let's do some more questions here, everyone. Let's do some more questions here. Let me see how many questions we are left with. 1 and 2 and 3 and 4 and yes, 4 questions we are left with. Okay, 4 questions we are left with. Let's do that. Okay, yes, everyone, let's do these 4 questions. Okay, so one by one I'll pick all these questions. Freezing point depression of 0.1 molar aqueous solution of monobasic weak acid is this. The dissociation constant for the acid is going to be what? Molality is equal to molarity. Molality is equals to molarity. Freezing point depression of this much molar aqueous solution of monobasic weak acid is this. Dissociation constant you have to tell. Kf value they have given you. See, first you will find the value of Vant Hoff factor from here. Okay. So can I just write it as delta Tf is equals to I into Kf into molality. So Kf is given to be something that is 1.8. Molality is given to be 0.1. And Vant Hoff factor you have to calculate. Delta TF is given to be our freezing point depression is 0.20 degrees Celsius. So I is equals to 0.20 divided by 1.8. This is 0.1, right? Solve the value of Vant Hoff factor here, and here it will be I is equals to, because it is dissociation, I is equals to 1 minus alpha plus n alpha. Here, because it is a monobasic acid, so n is going to be 2, right? So put in the value of I here. Let's see what is the value of I that you got from here. I value will be 10 by 9. Okay, that you will get from here is 10 by 9. So I'll just put the value 10 by 9 here. This is what you will solve from here, right? Okay, this is what you will solve here. Easily you can see that this will cut to this side. Okay, this then it will be 10 and this is your 9. This and this will cancel out. So it will be 10 by 9, right? So this is 1 minus alpha. We have no idea. N is 2. So it will be 1 plus alpha only. If you put the value of n as 2, I is equals to 1 minus alpha plus n alpha. We put the value of n as 2. So it will be 1 plus alpha, right? So value of alpha will be 10 by 9 minus 1. That is going to be the answer here. That is nothing but 1 by 9 is going to be the answer here. Okay, 1 by 9 is going to be the answer here. You just need to solve it and you will get your answer here. right? Acha, wait a minute, what they are asking you? The freezing point, the dissociation constant is what they are asking you. Wait a minute. So sorry, I have calculated degree of dissociation, okay? Dissociation constant for monobasic acid is also not a big deal. That is Ka is equals to C alpha square by 1 minus alpha. That is the direct formula. If you ask me, ma'am, how you got this formula, uh, that also we can do here. Where should I paste it? Chalo. I'll do this here, right? That also we can do. Not like a very difficult formula, right? So this is H, this is A, give rise to H positive plus A negative, right? If you see, this is, let's say this is C, this is 0, this is 0, this is C minus alpha, this is alpha, this is alpha, right? So what you will see here while calculating the value of Ka, that is going to be Ka, that is dissociation constant, right? So how you will see dissociation constant is equals to, this is alpha value, right? That is your reactant side. This will be C minus alpha, right? Divided by, wait a minute, this should be C minus, concentration is C na, so it will be C alpha. Wait a minute. It should be C minus C alpha, this is C alpha, this is C alpha, right? So here you can see that C minus 1 minus alpha, this is C alpha, this is C alpha, right? Okay, so Ka is going to be C alpha product by reactant, so C alpha, this is the value of equilibrium constant of product by reactants, C alpha divided by C1 minus alpha, C will cancel, so you will have C alpha square by 1 minus alpha. That is the value of a monobasic acid. And in NEET, they have asked you not monobasic acid, triprotic acid, right? In NEET 2025, they have asked you triprotic acid, that we will do in ionic equilibrium. Okay? So in other chapters, they only include monobasic acid, okay? Because triprotic acid, tribasic acid, that will be a higher level, right? That individual question they can ask you, but not in a mixture, right? So here this is, that's how you got this value. Now you just need to put in the values here of Ka. Ka will be equals to, you can directly write it as C alpha square as well. See, concentration, that's why they told you molality is equals to molarity. So molality is 0.1, so molarity is also 0.1, right? So concentration is expressed in molarity. So that's why we'll put it as 0.1 only. Alpha is nothing but that is the value that we have got is 1 by 9 divided by 1 minus 1 by 9, and solving this you will get your answer here, right? Okay. Once for that you really need to watch concentration terms lecture. You can go and watch it, because at this point in the ending of solution chapter I can't teach you mole fraction, right? Okay, that is what I have taught you in the first lecture. Okay, so you can go and watch that. So after this you can simply use this and you will get your answer, right? This will be, wait a minute, 1 minus alpha C alpha square. Okay, it will be like this. Okay, after solving you will get your answer, right? Okay, next is 2 moles of each ethylene glycol and glucose are dissolved in 500 gram of water. Boiling point of resulting solution is what? See, they have given you 2 moles of each ethylene glycol and glucose. Two things are given to you. Ethylene glycol and glucose is given to you, right? 2 moles of each. That means this is also 2 moles, this is also 2 moles. Dissolved in 500 grams. This is dissolved in 500 grams. I think this we have done before as well. In the I think in the previous class only we did this, right? The boiling point of resulting solution is what? Okay. See, boiling point is nothing but, if you see, this is the aqueous solution, right? Delta B is equals to I into M into Kb, right? Ebullioscopic constant is given to you. Molality, you have to find it out, right? And what else it is given to you? Vant Hoff factor of glucose is 1 only. Ethylene glycol is also 1, so you don't need to find it, right? So you can just, it is actually not a question of this, but yes, you definitely can get confused in the exam, right? So it will be simply Kb into molality, molality into Kb. Now you have to find out the resultant molality here, because each of them is 2 mole and 2 solutes you have here, right? And you know what they are asking? The value of resulting solution, that is they are asking you Tb minus Tb naught. This is elevation, so it will be Tb minus Tb naught m into Kb. Tb naught is nothing but, if you talk about in Kelvin, that is nothing but it is, boiling point is 373 Kelvin, right? Okay, so they are asking you the value of this Tb. This is minus 373 is equals to molality into Kb. Now Kb is also given to you. Kb is given to be what? Kb is given to be 0.52. Molality is what you need to find here. See, molality you will find it by, because it is that each of them is 2 mole, right? So you will find that molality of ethylene, it is going to be number of moles divided by mass in kilogram. If it is in grams, then you will have to multiply it by 1000. This is 2. This is 4 is the molality. Molality of glucose is also the same. Glucose is also number of moles divided by mass. And here it is 2. So it is 4. So it is 4 plus 4. Molality total is 4 plus 4, that is 8. So we'll put here that is 8. Okay? So we'll put here that is 8 and you will get your answer of Tb here. Tb is equals to 8 into 0.52 minus plus 373 Kelvin. That is going to be the answer of Tb here. Okay, okay, after solving, what you will get is the answer will be 4.16. You will add here and the answer will be 377.3. That is A will be the correct answer here, right? Okay, chal. I think this is the last question, is it? Yes, this is the second last question actually. Okay, great. Let's do this. We have 3 aqueous solution of NaCl labeled as A, B and C with concentration 0.1, 0.01 and 0.001 respectively. 3 aqueous solutions you have of NaCl labeled as ABC, A and B and C. 3 solutions you have here of NaCl. Okay, they are saying that with concentration, this is 0.1, this is 0.01, this is 0.001. The value of Vant Hoff factor of these solutions will be. Let's talk about concentration and dilution, right? With that, you will be able to answer this, right? Let's talk about concentration. See, can you see here what is happening? Concentration is decreasing. Can I say dilution is increasing? Can I say if concentration is decreasing, dilution is increasing? Yes, everyone. Now see this very carefully. What is happening here, right? The concentration of the solution is decreasing, right? That means it is dilution is increasing, right? If you're adding more water into it, right? Because dilution is increasing, it's like you were seeing someone, like you were just looking at someone and now too much of chaos is there in the mall or somewhere you were, right? You were like looking at someone and too much chaos is there in the mall. Now what will happen? You won't be able to see them, right? Same thing is happening here, right? So when you are diluting it, adding water, it's very difficult for the molecules to interact with each other, okay? The interaction between ions, it decreases because too much water you have added, right? allowing more dissociation and allowing more complete dissociation, right? So if ions are not able to interact with each other, that means they will walk separately, right? More dissociation will be there. It's like when the teacher in the class, when you have one teacher, you are not silent. When you have three teachers, three examiners standing on your head, right? You are more disciplined. You are not interacting with each other. You are separately doing your like test, right? So they are not interacting. There is complete dissociation. Therefore, practical purposes, Vant Hoff factor approaches its theoretical maximum value. What is Vant Hoff factor? More the dissociation, more will be the Vant Hoff factor. So we can say when the concentration is least, in that case, dilution will be maximum. That means interactions will be least, dissociation will be maximum. Hence, Vant Hoff factor will be maximum. So answer will be B is the correct answer here. So I'll just write here, concentration decreases, dilution increases. That means interaction decreases, right? That means dissociation increases, interaction is less. So Vant Hoff factor, that also increases. So answer will be C. B is the correct answer here. Okay, right? These are important questions. This is your JE question, JE PYQ. So that's why this is important for the NEET aspirants. Okay. Now let's see this here. Which of the following aqueous solution will exhibit highest boiling point? Which of the following aqueous solution will exhibit highest boiling point? You need to see the highest boiling point here, right? Can you see molarity is same in three cases? The boiling point is highest means one thing you should need to be clear, that this is dissociating. So this cannot be the reason this is dissociating, because you know that highest boiling point means TB has to be more. See this thing. Delta TB is nothing but TB minus TB naught. This is constant, right? If this increases, let's say if this is 10, this is 5. Let's say this is 10. Let's say this is 50. Okay? If this is increasing, let's say I'm making it 12, we know that this will also become 70. Okay? That means if this is increasing, this is also increasing. You can see this with the help of numbers, right? So we can say that if this increases, this also increases. That means if TB needs to be more, that means change needs to be more. If TB more, change will be more, right? And we know that delta TB is directly proportional to I, M and KB. These three things. Now KB aqueous solution means KB is constant. Okay? Aqueous solution will exhibit, I am assuming that molality and molarity are same, right? First thing is it depends upon the Vant Hoff factor. For an electrolyte, it is less than or greater than. See, there is no association. Only there is dissociation. And for dissociation, Vant Hoff factor is less than 1. For non-electrolyte, it is equal to 1. Wait a minute. That's not less than 1. That's greater than 1. है ना? For dissociation, it's greater than 1. Vant Hoff factor is greater than 1. Wait a minute. Vant Hoff factor for dissociation is, yes, this is 3. This is also same. In this case, you have 0.01 urea, which is I is equals to 1. And here also I is equals to 1. And molarity is also less. So this 2 cannot be the possibility. Highest boiling point, they 2 cannot exhibit. But if you talk about this and this thing, this is a 2. If I talk about 100% dissociation, I is equals to 2. Here I is equals to 3. So A should have the maximum. है ना? हाँ. ठीक है? That's how you can calculate this. ठीक है everyone? How you calculated it? I have not solved it like this. ठीक है? You don't need to solve. Just remember that this is This is a non-electrolyte. In these cases, I is equals to 1. Okay? First thing is you will eliminate this thing. See, simple is here molarity is minimum means delta TB is minimum. So this is eliminated. Out of these three things, molarity is same. I am assuming that these two are same because no information is given regarding that. This I is equals to 1, but in this case I is greater than 1, this case I is greater than 1. Here the differentiate, so this is also eliminated. So here n is equals to 3, here n is equals to 2. So we know that more the value of n, more will be the value of I. So that means A will be the correct answer here. Right? Okay. Yes, everyone. Got it? That's it. That was about your solution chapter. And we have completed a lot of questions also on that. Right? Now, who will answer the homework in the comment section? First homework I have given you here. Evaluate the following statements in the correctness. You have to tell that choose the correct answer from the option given below. You can take the screenshot here, right? A, B, C, D, which of the following will be the correct answer. Take the screenshot and answer this in the comment section, right? Okay. And this is the second question that you have to answer regarding this. For a solution of gases A, B, C and D in water at 298 Kelvin, the values of Henry law constant are this. Respectively, in the given graph, the lines marked P and S correspond to which of the following? This is a question based on Henry's law. Take a screenshot of this as well. Okay, right? Okay, students. And that's it. This was your homework and this is our Vedantu NEET English official Telegram channel. If you're looking for the updates regarding my lectures, regarding NEET, anything, that will be in the Telegram channel only, right? And students, for all the students who are looking for a really good batch, let me just show you that. Wait a minute, right? Let me just show you a very interesting batch, right? Those who know the name of the batch. How many of you know? Name of the batch, which is very close to the NEET aspirants, right? A thing which is very close to the NEET aspirants. What is that? What is that? DNA, right? Doctor aspirants, right? Doctor NEET aspirants, DNA, right? So for all of you, we have this batch that is DNA NEET 2026 batch here. You can see students, right, in this batch, we are taking live classes. You will be provided with mock tests, you will be provided with the modules, and you will also be provided with these kind of QR cards here, right? That is your short, quick revision cards, right? So all these things are provided in the DNA batch itself. The batch is right now at discounted prices at 3999. 3999, yes, at 3999 here. And you can see the course here. See, 3 variants are provided to you. If you are looking just for the batch in which modules are provided to you in the soft copy, and you are provided with the Tattva modules, right? And mock tests are taken. You are provided with the test series, right? But on the online platform itself, right? And daily live classes, doubt solving, everything is there, right? But if you are looking for a batch which also provides you the quick revision cards in the hard copy, that will be provided to you in your home, right? That will be delivered to you like this, right? These are your quick revision cards, right? So that is at 4999, right? And if you want that, ma'am, I want, ma'am, Tattva modules also in hard copy. Ma'am, I also want, ma'am, this modules, this quick cards. Ma'am, I also want Tattva modules, I'm saying, I also want AITS in hard copy, right? Then that will be provided to you at 5999 here, right? So these are the variants that you have. You can always go and purchase that, right? The batch has already started, right, on 30th of June 2025. So guys, you are 1 day away from that. I would advise you go and purchase that, because that is going to be very beneficial for you, because we are just 10 months away from NEET 2026, and for that you have like You need to utilize these 10 months, right? For that, you definitely need a good mentorship and guidance that we are providing in the batch itself, right? Okay. So once I'll definitely wait for you in the batch, because the batch classes are going on, right? And like in batch classes, you know, the feeling is entirely different. If you love like sessions on the YouTube, you are going to totally fall in love crazy with DNA batch, right? Because in the batch, the personalized attention that is given, even on YouTube, we provide you personalized attention. In batch, we also see that whether this question students are answering right or not, what is your leaderboard score, how you need to improve, all these things are provided in the batch, right? Okay. Yes. Okay, then thank you so much, Ria. Thank you. Okay, then bye-bye. I would love to see your comments also in the comment section. Right, whatever you have for like if you like want to appreciate me regarding the content that I provide to you, you can always write it down in the comment section, because that also makes me feel happy that you guys are appreciating and you guys are enjoying the sessions, right? That makes me feel so happy, right? Okay, then students, bye bye. Take care. See you all in the next class. Bye bye.